Okay, so in this particular problem here, if we want to find the eigenvalues, we know we set up want to find the determinant of this particular matrix has to be 0 to make it singular. And we multiply it out, I know it's 5 lambda minus lambda, 4 minus lambda, 0 is the product here, plus 0 is 0. And so I know my first eigenvalue is 5, and my other eigenvalue is 4. And so using eigenvalue of 5, I know that 0, 0 minus 5, I plug 5 into here, is going to be minus 1. And when that is the case, I know I'm going to multiply by xy equals 0, 0. The first one says 0x plus 0y equals 0. That's what the top one will tell us, which means x and y at this point can be any numbers at all. When you do the next one, it's minus 5x minus y is 0, which means that y is equal to negative 5x, x. And so if x is 1, y is minus 5. And so here is the eigenvector. You could also get this particular one, or if you really wanted to go 2, 10, and so on and so forth, these two are the most common shown. And that comes from the fact that this scribble here really says minus 5x. But the one that's more challenging is the 4. When x is, or lambda's 4, the top says 1, 0, and the bottom says minus 5, 0, times xy has to be 0, 0. So that means x plus 0y is 0, or I can also say minus 5x plus 0y is 0. And in essence, these two equations are the same because I can multiply through by a negative 1/5 and get it out. So let's just concentrate on this value here. And in here, it's saying x plus 0y has to be 0. And so I know that this particular term is always 0, 0 times y. And so in order for x plus 0 to be 0, I know that x has to be 0. There's no choice about that. Now the y though, y here, this y could be 1, it could be 2, it could be 3, it could be any number I want. And so I can really, in my eigenvector, I can make this 1, or I could make it 0, negative 2, or I can make it 0, negative 101, and 0, and a 2, on any crazy number. But in essence, we try and pick the simplest one. All of these are correct, but this is the simplest version. And so because I know that x plus 0y is 0, and x has to be 0. There's no choice about that. In order for this equation to be 0, this has to be true. I know x is 0, and y really can be any number I want, because when I multiply it, that will always be 0. And so then when I am going to make my matrix, when I have 5 and 4 as my diagonalized, if I'm going to go here, I know that it's the 4 gets 0, 1, the 5 will get 1, negative 5, and then over here I have to do the inverse of this particular matrix, and I think that's good enough to get the essence of the problem.